Automatic transmissions are often described as effortless, intelligent, and almost impossible to mess up. Indeed, modern systems have come a long way, from purely hydraulic control to highly adaptive electronic shift strategies. But underneath the smooth driving experience, an automatic transmission is still managing friction, hydraulic pressure, and heat every second. And when certain driving habits interfere with that balance, the transmission doesn't fail immediately. It compensates. Over time, though, that compensation turns into wear. You might start noticing slightly delayed shifts, a bit of slipping, or higher temperatures. And eventually, those small effects can add up to serious mechanical problems. In this video, you'll learn which 5 everyday driving habits quietly accelerate that wear, and what's actually happening inside the transmission when they do. To understand why, it helps to look at what's actually happening inside. A typical automatic transmission is built around 4 main elements: a torque converter, planetary gear sets, clutch packs, and a hydraulic control system. The torque converter replaces the clutch you'd find in a manual car and transfers engine power through fluid instead of direct contact. The clutch packs, on the other hand, engage different gear ratios by pressing friction plates together under hydraulic pressure. Every gear change is essentially a carefully timed sequence where pressure is applied and released to smoothly transfer torque. Unlike a manual, where you control that process directly, the transmission is doing all of this for you, based on software, sensors, and fluid dynamics. That means it works best when conditions stay within what it expects. The first habit that disrupts this system is shifting between drive and reverse while the car is still moving. It's something a lot of drivers do when parking, just a quick switch to save a second or two. But mechanically, it's a harsh move. Inside the transmission, components are still rotating in one direction when you suddenly ask them to go the other way. The clutch packs responsible for forward and reverse have to absorb that entire difference in motion. Instead of a smooth engagement, you're forcing a rapid, high-load friction event that the system wasn't really designed for. Even at very low speeds, the forces involved are larger than they seem. A car rolling at just 3 miles per hour already carries enough kinetic energy that something has to absorb it when you change direction. If you don't come to a complete stop, that something is mostly your transmission, specifically the clutch packs and the torque converter. They convert that energy into heat, and for a brief moment, that heat can exceed what the transmission fluid can comfortably handle. Do this repeatedly, and the friction materials wear faster, seals degrade, and over time you end up with slipping or delayed engagement. The second habit is holding the car on an incline using the throttle instead of the brake. This is especially common in stop-and-go traffic on hills. What's happening here is less obvious, but just as important. The torque converter is designed to slip slightly. That's how it allows smooth takeoff. But when you hold the car in place with the throttle, you're forcing it to stay in a constant slip condition. The engine is trying to push the car forward while the brakes, or gravity, are holding it back. That constant slip generates heat, and not just a little. Even in mild situations, the torque converter can be dumping several hundred watts of heat into the transmission fluid continuously. Over time, that pushes fluid temperatures beyond the ideal range of roughly 175 to 210 degrees Fahrenheit. Once temperatures climb, the fluid starts to break down. It loses viscosity, meaning it can't maintain hydraulic pressure as effectively, and it becomes less capable of protecting internal components. That doesn't just affect the torque converter, it impacts every shift the transmission makes. The third habit is selecting park before the car has fully stopped. It might feel harmless, especially if the car is only rolling slightly, but internally, it's a mechanical shock. When you shift into park, a small metal component called the parking pawl locks the transmission's output shaft in place. It's designed to hold the car stationary, not to stop it from moving. If the vehicle is still rolling, even slowly, that pawl is forced into a moving gear. Because of the gear reduction in the drivetrain, even a small amount of motion at the wheels translates into a surprisingly high force at the transmission. The result is a sudden impact load on a relatively small component. Over time, that can lead to wear, chipping, or deformation. You might start hearing a clunk when shifting into park, or in worst cases, the parking mechanism may no longer hold the car securely. The fourth habit is shifting into neutral while driving, often in an attempt to save fuel. This used to make sense decades ago, but in modern vehicles, it's mostly outdated and sometimes counterproductive. In drive, many transmissions use engine braking and torque converter lockup to improve efficiency. When you shift into neutral, you're disengaging those systems entirely. Then, when you go back into drive, the transmission has to reconnect everything under load. That means the clutch packs have to synchronize the speed of the engine and the transmission input again, which involves friction and wear. Similar to a gear shift event, if this happens frequently, it adds up. And here's the key point. Modern engines often cut fuel entirely during deceleration in drive, meaning you're already saving fuel without shifting to neutral. So you're adding wear without gaining efficiency. The fifth habit is neglecting transmission fluid maintenance. Unlike engine oil, transmission fluid often gets overlooked, but it plays a much more complex role. It's not just a lubricant, it's also a hydraulic fluid and a cooling medium. Over time, it degrades due to heat, oxidation, and contamination from tiny wear particles inside the transmission. As the fluid ages, its properties change. It becomes thinner, less stable, and can start forming deposits on internal components. These deposits can interfere with valves in the hydraulic system, leading to delayed or inconsistent shifts. At the same time, particles in the fluid increase internal wear, almost like a fine abrasive. Regular fluid changes aren't just preventative, they're essential to keeping the entire system operating as designed. The practical takeaway is straightforward. Come to a complete stop before changing direction. Use the brake, not the throttle, to hold the car on a hill. Avoid unnecessary shifts into neutral, and treat transmission fluid as a critical service item, not a lifetime fill. These aren't complicated changes, but they align your driving with how the transmission is actually designed to work. In the end, automatic transmissions aren't immune to bad habits. They're just very good at hiding the consequences in the short term. The underlying mechanics don't change, friction still causes wear, heat still needs to be managed, and materials still have limits. Once you understand that, it becomes clear how small, everyday actions can have a measurable impact over time. If you want more breakdowns like this, where engineering meets real-world driving, consider subscribing to Engineering Manual